What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to join the community debate, then go to nathanoakley.com and check out the Flat Earth Debate forum, which you should definitely all join. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion right here, right now, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show. And one last time, if you are new to the channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, if my child will allow me, I'm going to do a very quick shout out to all of my Patreons. So shout out to Alistair. Let's just move my mic and get a bit closer to the screen. Billy Highvolt, shout out to you. Burn fat till my stomach is as flat as the earth. Shout out to you, my friend. Chow Young Cat. Dank, shout out to you, my friend. David Wayne Foster, Edwin, big appreciation to both of you. Felix, Fireball X, a new Patreon. Thank you very much for joining my Patreon supporters. God Rockin', thank you very much. Jeronism, same to you, my friend. Kirsten, big thank you to you. Matt, Michael, Paige, Renee, Rune, Sam, Sweet Equity, Texas Mike, theflatearthchannel.com, and Tina Baker. So a massive shout out to all of my Patreons. So we are joined by quite a few people in both Discord and Google Hangouts on air. So I'll say a very big shout out to everybody who's in there. Gives you some introductions. We've got Spurs Chemo, Sleeping Warrior, hello. Paul, Chocolate Sane, and 10th Man.
Good morning.
Good afternoon. Good afternoon.
Good morning. Mic check.
Hold on, just before, don't be too keen. I'm going to introduce some people on Discord too. So before we get into it, we've also joined by, is it Dougie, Earth-Shaped Investigator, Flatulent Unicorn, oh god, these names are terrible. RC Moisty and Red. Very good to have you all in the Discord server.
Good to be here.
Hello.
All is good.
On you
well,
go.
Let's get the show rolling.
Indeedy.
Any signs of Earth curvature?
Dougie?
No.
Nope.
Any signs, mate? You're a globehead. You're always on mute. You never say a word.
I like it.
Whoever that is, they sound really muffled. Whoever that is.
It's okay. He's saying, come on, you're a globehead. He's talking to somebody else in the Discord server, telling them to come off mute. I appreciate the sentiment, Flatulent Unicorn.
No worries. It's just that he's always on here. Never says a word. He's a self-proclaimed globehead, and he just...
No, I'm listening. I'm at work.
Right? When you get to the gravity question, 10th Man,
you can listen on YouTube, on the live stream on YouTube then.
Gravity.
I'm here, guys. Don't worry.
Okay, we'll give you a nod when we get to gravity, Spurs. So
yeah. Okay.
Any scientific evidence of gravity? Oh, Spurs, by the way.
Yeah.
This is
yes, yes. On a flat Earth, we're told there is a pressure, an atmospheric pressure. In order for this pressure, you need a force. And I would say if there is atmospheric pressure, then there has to be gravity. So was that not proof or evidence to you of gravity being atmospheric pressure? If something is pressing on our bodies and on the Earth, wouldn't it make sense there was a force?
Wrong.
10th Man?
Okay, real quick. Define force.
Oh, well, I'm asking 10th Man. He asked the question. So I'm saying to 10th Man, wouldn't you say if there is a force,
Excuse me. Nathan asked the question. I didn't ask the question, but I'm willing.
Okay, great. Let's do it then.
Define what Paul said first, please.
Define what?
Force. Define force.
Force. Force would be an action, something required to give pressure.
A mass that is accelerating.
Okay, so 10th man, I've answered your question. Now, we agree that that's the definition. So now, is there a force? What is that force that is pressing the...
Wait. Did I say I agree with everything?
Okay, so what do you disagree with then? Let's get into it.
Well, no, just keep talking. But I haven't agreed to anything, but keep talking.
Well, I've finished, so back to you.
Well, what have you finished? Then state what you're trying to say.
You asked me for a definition of force.
Well, actually, Paul did, and I seconded it.
Okay, next.
Okay, next.
What's next, 10th man?
Your example.
Any signs of axial rotation of the Earth-based variety?
Oh, no.
Wait, you're skipping the gravity question there. You're
Spurs,
skipping the gravity question, 10th man. What's wrong with you?
Yeah, we got the gravity question. Oh, hold on, guys. Hold on. Let's get this train wreck back on the rails. What's your claim, Spurs? What are you actually claiming?
That there is a sign of gravity.
And what is that sign?
Atmospheric pressure.
Yo, really? You have that scientific evidence?
No, I'm saying that's a sign that we have.
We don't
want to hear it. If you don't have
right.
scientific evidence of gravity, we don't want to hear it.
Question is specifically phrased, any scientific evidence of gravity. That's why you have Travis going, scientific evidence of what?
Well, it's been scientifically proven that there is atmospheric pressure, right? That's what you agree to. Otherwise, you wouldn't accept it, right? Obviously, there's science that backs atmospheric pressure. Otherwise, you wouldn't have adhered to it.
Is there?
So obviously, well, that's what you're... Well, we don't have atmospheric pressure. I don't understand. You were saying last week I'm a pressure denier. So I'm saying that if there's pressure...
Spurs, let me reply. Yeah? Let me reply, please. Right. If there's a cause and effect relationship that needs analysis, then there may be, or may have been, a scientific study that conforms to the scientific method in regards to an effect caused by pressure. That doesn't necessarily mean that there's scientific validity being given to it, because it's not a cause and effect relationship, is it?
Precisely.
So why do we talk about atmospheric pressure as a thing then? If it's not,
it is a thing.
If it's not being
because we sense it. You don't, apparently.
But the ball earthers sense rotation, they sense curvature.
Do they?
Does it mean it's here?
Do they? Do you show me where they've sensed it?
Well, they've never brought any evidence of curvature. They brought their senses, what they think.
That's not senses.
So,
thinking
wait,
isn't a
Globers
sense.
have told you that they've sensed rotation? I've never heard that.
Have they ever brought evidence of rotation?
Hold on, Chocolate
Absolutely
and
not.
Spurs, hold on.
Actually not. So
Hold on, one second.
Spurs, evidence
Spurs.
of rotation.
Hold on, someone said something from the Discord server. Do you want to go ahead, whoever it was that was trying to interrupt? Or maybe not.
Thank you.
I just want to say that, you at the moment, John and Dal, all this idea of a pushing, pressing on us, that you were all wrong. Because you've just said there is no science to prove that there is a pressing. There is no science for gravity.
We don't
But
need scientific evidence.
if you're accepting a pressing with no science, then why are you not accepting gravity?
One word. Remember I told everyone to tell Spurs one word? What's that one word, people?
Barometer.
Okay, can you demonstrate this for us? Because that's what you want, right? You want to demonstrate.
Barometer. Okay.
Well, hold on.
Now go back to second grade and do a little
hold on.
barometer test, and it's over for you. Okay. Thanks.
Okay, so do Cavendish, and it's over for you.
Hold up. Why? Why is the
Cavendish
barometer
have to do with it?
somehow?
We're talking about gas pressure now.
Everyone be quiet.
Barometer.
Stop.
A barometer is
Hello.
not a Japanese
Hello. The guy that was trying to
have
get
this
it.
with 10th man, so he didn't turn it
Spurs.
right?
Somebody's trying to talk to you. Go ahead from
You're
Discord.
shouting at me. 5 people. Why?
That's what I'm trying to stop that from happening. Go ahead, guy from Discord. Why
Thank
would
you.
you interrupt a guy from Discord, right, to start audio chaos, and then when I clear the airwaves for you, you literally don't say a bloody word? Are you trying to piss me off?
Who is it?
Who was?
I'm pretty sure it was that RC Meisty guy. That's the
Okay.
reverse
Okay, I'm
reification
going
guy. That guy.
Wait, what is the what's
I'm
the
going
problem
in.
with me?
Sorry, Spurs.
RC
Surprisingly,
Meisty.
that wasn't at all your fault. Did I say hello to the one?
Hello. What's up?
Hello, the one. So, Spurs, you don't... Let's just...
No, but Nathan, this is why I'd rather not do this with you, because it's going to get heated, it's going to get wild, and we don't want that kind of aggression for something that can be understood with simple conversation. So
Okay.
I'm just saying that if we have proof or evidence or scientific evidence of atmospheric pressure, well, then we can go from there. But we're expecting something.
And I've just tried, Spurs, to explain that you're misunderstanding what these terms mean. Yeah? Having something that is observably obvious doesn't make it scientific. Having a cause and effect relationship that's been valid by hypothesis-driven systematic experimentation, that makes it scientific. Observing the bloody obvious does not. So you don't need to science atmospheric pressure.
Well, you do, because again, there's a press that I don't feel, there's curvature that I don't see, there's a spin that I don't feel. So there's phenomena in nature that cannot be registered unless you go underwater. That would be real pressure.
No,
But
sorry,
people-
that's just you, Spurs. That's just you, Spurs, Schemo. That's
Spurs.
just
Everyone's
you.
rumpusing him. I don't mind him getting to the end of his nonsense point.
What's wrong with the conversation? I'm just trying to make a calm point. I'm simply saying that, to me, real world pressure is felt underwater, where the deeper you go, the more pressure you feel. And now we're being told that this same pressure calculation is felt at sea level. Now I'm just trying to understand, how is it 14.7 at sea level and 14.7 under the ocean at 33 feet? That's very bizarre.
Right, but one thing we do know about it is that it is there.
Now, wait a minute.
Don't
He
you
said
agree,
something very...
Spurs, Schemo?
This is why I don't want to have an argument with someone.
It is there, isn't it?
If I go back and forth with Arwin's going to say, because it is, because you just
you just literally said it. You just described it. So I then asked if we could establish that it is indeed there.
Look, here is the pressure. This is how we measured it, and this is where it shows 14.7. We've never seen this. As far as I'm concerned, you could have said 20.7, 50.7, 15.7. That number was arbitrarily chosen for whatever reason, and I'd like now to know how they calculated 14.7. Is that too much to ask?
Go back to third grade and then go up through the scheme again. The primary school for you.
Shout out to theflatearthchannel.com, who says nothing, but gives me money anyway. Thank you very much indeed. Really appreciate your support. Thank you very much indeed.
You're telling me to go away and demonstrate something the same way that the ball earthers tell you, John, to go away and show that the earth is rotating.
Well, whatever, Spurs. I'm not dealing with you, because you need to go to Pete and Pete's show or something. You need to take your show on the road.
Yeah, well, you're telling me what the ball earthers tell you.
I don't care. I don't care what you say. Barometer. That's my answer. Barometer.
Okay, hold on, guys. Adam Meakin from the chat says 33 feet underwater is 2 atmospheres of pressure, not 1.
Yeah, and how did they get that's because they've added the 14.7 from sea level. How did you get the 14.7 to add it in the first place?
Barometer.
Yeah, let's have a look then, John. Let's see it.
Oh.
Exactly.
Do I need to show you a barometer, Spurs?
If you take a gauge and you go underwater from 0, the pressure will increase.
We're not going underwater.
1 PSI, 2 PSI.
We're not
going underwater. How a barometer functions.
Atmospheric pressure.
So if that's not
Why
how
are we
you
going
understand
underwater?
how a barometer functions,
if that's not how a barometer
it takes.
How did you get 14?
It measures the pressure differential between the tube and the stuff in it, and what is outside. Whatever is outside.
Oh,
whether
here
that
we
be
go.
gas pressure,
Pseudo thought.
whether that be liquid pressure, it's just the pressure differential.
Are
That
we?
is how a
Show it.
barometer works.
Well, let's see it. Has anyone on Earth ever seen a barometer work?
Yes, I've seen a barometer. I've held a barometer.
I say no, and they would
Oh,
never.
you say no? Well, I'm sorry that you say no. I'm sorry that you're constantly trying to gaslight everyone with that we don't experience pressure when we clearly do and have examples for that. I'm really sorry that you can't open up that single chance that
I say
everybody
you're saying the same thing to me that the ball earthers say to you.
Guys, can I just like try and diffuse the situation a little bit?
No.
Just by why?
I'm really joking.
Well,
Go ahead.
I'd like to not play devil's advocate, but I'd like to suggest a suggestion that Spurs may have a little bit of weight on. If I present my screen, Nathan, let me just pull this thing up. And I'm not doing this just to be contentious. I'm doing this because I think he might have half a point. I'm not saying I agree with him. I'm just saying that it's dawned on me something last
Get
night.
out right now.
Yeah, get out of here, Anthony. Are you going to entertain this
Save it for the
nonsense?
after show, Anthony.
Come on, let's have it. Let's have a look.
So,
My
all right,
word.
so
Don't rumpus him. Let's hear it.
all right, so just bear with me. Just let me make my point. When I was discussing with George Netanyahu last night, it dawned on me that the layers of the atmosphere that we're told, like the ice, the stratosphere and all the mesosphere and all them, they're effectively like layers that are inside this container, right? And we must be living in a contained environment of some kind because we do have gas pressure. What happens if we're the cherry tomato and everything below the cherry tomato is the earth? And the layers that the cherry tomato sits in, or us, are just the layers of the atmosphere, the different gases that are in the atmosphere. And if we didn't have a dynamic sun that mixed it all up and made it into a big dynamic system with the carbon cycle, the nitrogen cycle, and the hydro cycle, and all the other things that influence what goes on, could it not be that the layers of the air that the barometers are measuring are actually the density or the mass of the layer that we happen to be in that we call pressure?
No.
Maybe Spurs is right. Maybe
No.
it's measuring the mass of the volume that we're in.
No.
What is wrong with you?
Right. What you're looking at is layers
PSI.
of bonded liquids in layers. Gas isn't like that at all.
Just a suggestion. I'm not saying it is right. I'm just saying that I can see where Spurs is coming from. Maybe barometers are measuring the mass of the medium that we're in at the layer that we're at the time.
They're measuring the pressure
pressure.
differential, not the
Pressure.
mass.
Can I make another point? And this point, what I make
Hold on,
is that-
Spurs. Is that all you've got, Anthony?
I just think when you look at the definition of pressure within physics, you could make that fit what we're looking at.
Really, gas pressure. Really, go
I'm
ahead.
not saying it's right. I'm
Make
just
that
saying
fit.
that I can see Spurs' angle a little bit clearer now
Well,
because
you
I had the
can see,
discussion
you
with
need
George
to take
last
the
night.
mud-covered glasses
I
off.
can see it as well, but I also can see it well enough to know that is absolutely, unmistakably a mistake.
Okay.
It's
Well,
bigger
that's
than
what
that.
I
It's
said.
buffoonery.
The point I was going to make was any gas canister, pressurized canister. If you were to remove the liquid or the fluid from that
Oh,
canister,
God.
you would remove the pressure. So when you see a
Why don't you
gradient,
go to Jose's channel, okay, and run the ballers for the next few weeks? I think it's funny, but
Yeah,
I've about had enough.
I'll
of
have
this.
another
You're
back
not-
and
you're
forth.
lucky you're
with
not
you
in
there.
well,
Discord.
this has to
Ballers
be a sign of
and
gravity.
You
Then,
learned
because
your
how
lesson
is
from
pressure
that.
without a force? How do
Yeah,
you
you
explain
learned
this
your
force?
lesson from that. I know you're not in Discord.
John, how do you explain this force? What is this force pressing down on us?
What?
30 days in the hole.
What force pressing down upon us?
How do you have pressure, Arwin, without a force?
You have a container.
Well, there's the force of basically the molecules themselves bouncing back and forth.
Mhm.
That is kind of what in gas, because it's so easy for the gas particles to do. That's what causes gas pressure to basically expand in all directions until it hits an equal and opposite kind of force like a barrier, which
you're
would
saying-
be the container.
You're saying molecules bounce back and forth. So
Yes,
you know-
that's pressure. That's what molecules do. That's what gas pressure first and foremost.
Okay.
What
So
gas
we know
molecules do.
that
They bounce
we
in
know
all
that-
directions very loosely.
Okay. So we know that warm air rises, and those molecules are going up because of the temperature. They're warm. So how are they going back? Armin? What mechanism is drawing these molecules back?
Besides their displacement,
Mhm.
they also are subjected to the entropy of temperature. And as they go higher up, they go further away from the heat source on the Earth. And then there they mix in with the colder air that is around that spot. And then that same air will go stable, maybe go down. Definitely the moist within the air will start to hydrate again, turn into droplets, and that's how the clouds get there. So there's all kinds of interactions because of the temperature.
Exactly, because of the temperature. This is the only cause that will affect.
No, it's not. No, that's not what I said. First, the pressure differential makes it displaced.
What are the other causes?
The pressure differential makes it displaced,
Armin,
and then the temperature afterwards cools it down. It's another process.
Hold on, Arwin. Ask your question again, Spurs.
Yeah, so if if temperature causes the molecules particles to go up and go down, what other force is making things go down or up? If I have a particle,
Relative density.
that's a force.
Well, the relative density disequilibrium does seem to create force.
I had to define force, Arwin. Can you define force?
Force is energy that is basically causes to which matter is subject, as it were.
Right. So where do they get their energy? If a particle's going up because of temperature, that's their energy. Where is their other energy to make them bounce in a different direction?
Bounce in a different direction?
They're
not bouncing. No, you're talking about air layer. An air layer functions differently as separate gas particles.
Hold on. Just Arwin. Go on, Arwin.
An air layer and its average temperature is very different from separate gas particles and what they do as a mash.
I'm talking about the cause of their movement, Arwin. The particles, the air, the atmosphere, the cause of the direction.
Right. Well, what expands in all directions and all that is purely due to the condition of the molecules. But entire bodies of air and temperature and pressure, they displace in accordance to the relative density of the mash of it, not of the individual molecules.
Arwin, you haven't given me the force.
Relative density disequilibrium.
Demonstrate that force for me.
Riley, would you do the honors?
And I would say in that gradient, the temperature at the bottom would be different to the top, Arwin, and that is the cause.
He's not talking about temperature. You're not listening to what he's saying, Spurs.
Nathan, in a denser medium, the temperature is different to the thinner medium. You can't get away from that. You can't have a dense medium and have the temperature different to what it would be. You can only have one type of temperature in a low pressure and one temperature in a high pressure.
That's not true. That's absolutely not true.
Yeah, they may be correlated, but
I explained this in detail yesterday. There are two different relations concerning temperature and pressure. If you amp up the pressure, then the temperature in that chamber will also go up slightly, but not as much as the pressure overall does. Same way, if you amp up the temperature in a closed room, then the pressure will go up slightly, but not nearly as much as the temperature goes up. So there is a correlation, but it's not parallel, it's not symmetrical, or however you called it. It's not the same thing. It's not interchangeable. One follows the other. They're absolutely separate effects.
No, in a container.
Yes, and I just explained exactly why that is a fact.
Arwin, just let him respond.
What's wrong with this guy? So no, in a container, pressure and temperature go hand in hand. You lower the temperature, you lower the pressure. You increase the temperature, you increase the pressure. Now outside, in the real world where you stand, you can't control any of that. And we only feel the effects of temperature. Zero pressure. Now, if there is such a pressure outside, Arwin, instead of giving me your religious, we do it, they've got it. Can you demonstrate this?
Shut the hell up, you freaking Brenda wannabe.
Right, hold on. If you're giving up, Arwin, no. Someone else then. If you don't want to, someone else address this question. He's making a claim.
Freaking called my explanation.
No worries. Go ahead, Arwin.
Okay.
Go ahead.
take over.
QE.
Very good explanation.
Arwin. I heard it. It was good. I agree.
Thank you.
Forced the relative density disequilibrium was a good answer. It was very concise. You gave a good preamble beforehand. He just hand waved it. Now, if you're pissed off with it, I don't blame you. But John's desperate to try and get in. Just don't rumpus him.
Okay, I'll be on mute.
Thank you.
It won't take long, Arwen. Ready? Barometer. Thanks.
Condenses
Prosecution
in
rest.
cold. Yeah, they condense in cold weather. If that barometer freezes, you can't take a pressure measurement. They don't work. Metal contracts in cold temperatures.
What temperature does mercury freeze at?
30, 40, minus 30, 40. You'll get no readings after this because it will freeze. The particles will condense.
You know, there are other forms of barometers,
Let's
right?
see those other forms of barometers.
Yeah, you can just simply use
Yeah,
other
I can,
materials
but you
specifically
can't.
designed
Yeah,
for
I
a
can, but
natural
you can't.
temperature ranges to
Yeah, I know
overcome
I
the
can,
problem
Armin,
of
but
the
why is it you
mercury
can't?
freezing, for example.
Yeah, I can, Armin, but why can't you? Why can't you? demonstrate
Barometer.
They freeze up at cold temperatures.
Prosecution
They
rest. Well, just
expand in
don't. Just
warm
go somewhere
temperatures.
where it's not freezing.
Yeah, say the full sentence, John. Barometers freeze in cold temperatures and expand in warm temperatures.
Well, then just go somewhere where it's not freezing. Then.
How are you going to control the atmosphere?
No, John, he's misleading you. There are barometers specifically designed for very
The only
cold
pressure in reality is water
Yeah, I know.
pressure, liquid pressure.
I know.
Any device.
I know. I really don't care.
Well, like I said, barometers, all of these devices, they read liquid pressure. That's the only real pressure that we measure. And in any canister, as I've just
You're
said,
an
if
idiot.
you remove
Get
the
out.
liquid,
Go-
if you
go
drain the
take your
water,
show.
if you drain
Go
the
take
water
your
from
show
any
on the
canister,
road.
you remove the
Go
pressure.
to Pete and Pete's. Right? The water's an element. Is that Pete and Pete's? Am I right in that?
Yeah, Pete and Pete.
Pete and Pete. Yeah, go to Pete and Pete's or go to Jose's.
Who's
Bye.
Pete and Pete?
Don't let the
Hey, I'd
door
like
hit
to
you on the way on a, in the
Spurs,
butt on the way out.
I'm a little confused. Are you trying to say that the only pressure is liquid pressure?
Water pressure. Yeah.
There's no such thing as gas pressure. We're still
there is
doing
gas-
that.
There is
That's
gas
all-
pressure.
that's the deal.
There is gas pressure, but in a container, a real container. So we don't live in a container. What container do we live in?
But then how do we have the gas pressure in the first place?
We don't have
That's-
gas pressure. We have gas. It's not
That's
pressurized.
what he's saying. There's
It
no
moves
gas pressure.
freely around. It moves everywhere it wants to go. It's not bouncing off any walls. If you look up the assumptions about gases, they assume that they are round, rigid spheres. They assume that they move in straight lines. They assume all kinds of things about gases. They don't know what the gases are doing, right? But in that presentation I made with Ranty, there's a guy who shows the atmosphere through a portal, and you can see the atmosphere as you wouldn't be able to see in an everyday situation. And he shows that all the atmosphere is going up, not pressing on you. It's going the opposite
I'm
way.
almost willing to pay somebody to kick him.
Well, no.
I'm almost-
let me just
I'm
let me
almost-
just try and reason with him once more. Okay, Spurs.
$50 on my PayPal will do fine.
Well, look, there's no need to kick me. Look,
I didn't even get. I didn't even get 3 seconds. I didn't even get to start.
No, because
Spurs.
I knew this would happen. Everyone's going to get
Spurs.
aggressive and angry and upset.
I haven't even started yet.
All right, sorry, go ahead.
Thank you. So, do you accept that gas is particles? It's molecules. That they are things. Do you accept that first of all?
They're things. They are something that we're still trying to work out what exactly they are.
Would
But
you
yes,
accept?
I agree.
Would you accept that at a microscopic level you could see gas particles?
Again, if you were, I know you're asking a question. If you were to look at the particles in a microscope, you would see a fluid, like a liquid.
No,
Something
you would
moving
not.
around.
What?
Okay, no, that's okay. I didn't think I'd have to take a step further back, but I don't mind. Okay, do you accept that at a fundamental level, a liquid, not fluid, a liquid is bonded together, whereas a gas isn't? It's separate and free to move. And the thing I'm talking about when I say it is what I'm asking you to, or I was asking you to accept, is a real thing.
No, I agree. What you just said, I agree. They're not bonded together. They're freely moving. What you just said, they're freely moving around.
And they are the thing I asked you to get the first concession in this regard. They
No,
being...
but
You're
no, but
talking...
for sake of begging the
Spurs!
question, I'll go
Spurs,
with
you
it,
ask me why I get aggressive. This is why. Because you're pissing me right off. I'm in the middle of getting clarity. You've made me take a step back into retarded. Let's not. Let's calm down. Take a breath. Spurs. That which we are referring to when we say it is unbonded, do you accept it is an actual thing? Like a dot if you were to draw it on a piece of paper to represent that thing that we are calling it?
Yes, for the sake of argument, yes.
So a little dot that I could draw on a piece of paper would be representative of...
Yeah, like Conspiracy Cats draws those dots. Yeah, I would accept that.
Fine.
Yeah.
That's all I wanted, a yes. Bloody hellfire. Okay. Now, I'm going to use something that's analogous. Not the same, but comparable. So imagine a tennis ball. Okay? It's like the dot of gas, but much, much bigger. Now, when I throw the tennis ball against a wall, would you accept that when it touches the wall, it presses on the wall?
Absolutely. Absolutely.
So it's a dot that can press on something, and when it presses, it causes pressure. The tennis ball.
Yes.
Right. Gas is exactly the same.
This is where the contention comes in, because now I'm saying the opposite. This tennis ball, you have to imagine it more like a jelly ball, right? So when this tennis ball presses against the wall, it doesn't bounce back. It hits the wall and drips down the wall, right? So when you have two jelly balls that are pressed together, you will have a liquid. I mean, very difficult to get two tennis balls and form a liquid. They would have to be of a jelly type substance to form that liquid, that fluid. Now, when you take these jelly tennis balls...
We're not taking jelly tennis balls. I didn't use jelly tennis balls. They're not liquid. They're not bonded. It's analogous to one particle of gas, one molecule. That's what it's the equivalent of. One. Not bonded, not jelly, not flowing, not talking over every single time I rebut your false equivalents that I did not use. It's not a jelly ball, it's a tennis ball. When it hits a wall, it causes a force, a pressure. It presses on it. Gas is the same. It expands in all directions, and when it strikes the walls of the container, it's pressing on the walls of the container in the same way a tennis ball is. That pressing is pressure.
Yes, it's not a jelly ball. It's a very self-confident ball.
I'm going to share my screen, Nathan. Share my screen if you don't mind. And I'm going to show you the assumptions that you are giving us about gases. And this is what I'm trying to say. So you've just given the assumption that gases are, rigid spheres. This is what science believes, that the molecules behave as rigid spheres. That's the assumption, Nathan. And as we can see, that in a container, they're not rigid balls because they liquefy. And if you look at all of these assumptions that science makes, they're nonsense. They have no idea.
Okay, you've just made an assertion. So you're saying that they... Spurs, please don't interrupt me again. You wonder why I get aggressive? I've told you once. Do I have to tell you a second time that interrupting me while I point out that you have made a baseless assertion, and I want you to back your baseless assertion about them dripping down walls and becoming squidgy? Where's the validity to this statement you're making?
I don't think gas actually literally physically sticks to the wall like some layer.
Due to the fact that every gas pressurized container has a fluid at the bottom. That's how you know this. They're not solid little balls at the bottom of the container, are they? They are compressed liquid. How do you compress tennis balls into liquid?
I'm not compressing tennis balls.
We've got a bit of confusion. We want to get it kind of cleared up.
It's an analogy. Can I just, sorry, Paul. I just want to draw a close. Okay. Paul, just want to draw a close. It's not saying gas is tennis balls. I made it really clear. I said it really slowly. It's an analogy.
It's the wrong analogy because they're not, as I showed here, they are not rigid spheres. That's the assumption. Now, you cannot demonstrate they are actually rigid spheres. How do you know they're even spheres? What gives you the impression that they are round
because
spheres?
It's matter. It's stuff. It's real stuff.
You're correct. You're correct.
Hold on. He's asking. I want to tell him. When you've got ice, the solid state, and then you've got water, it doesn't vanish into thin air and just not exist anymore when it becomes steam. It's still a thing. It's just no longer bonded. And those... Oh, for the love of fuck. Why are you interrupting me, Spurs? I'm asking you a question. Why are you continually interrupting me?
I thought you'd finished.
What, while I'm in the middle of a sentence? Okay, I'll try and continue, hopefully uninterrupted. You can see that it's stuff when it's ice. You can see that it's stuff when it's water. And in reality, in many instances, you can see that it's stuff when it's steam. It's still stuff. It's still hitting walls, and it still presses on the walls when it hits it. It's just as simple as that.
Indeed, and it can be confirmed by the mass of it not being lost into nothing. The mass remains. That's why you can have a closed off room with water in it, then change things about it. For example, the temperature, the water will evaporize. As long as the chamber is sealed, the entire weight of it will remain the same. Even though there is no more liquid in that room, it's now all in the form of gas. The mass, the perceived weight remains the same.
Right, ice.
Because it doesn't disappear into nothing.
Ice is water. Okay, water is not ice, but ice is water. So you can actually have water around the exterior of any object because ice, as you know, freezes around any object. So the way you're understanding the molecules, the particles, is not, what you can demonstrate. So you can demonstrate that they're akin to tennis balls or anything rigid like that, because inside any gas container, they liquefy. Now, balls, molecules to liquefy.
Okay, now shut the fuck up and respond to my question, you asshole. Asshole.
Go on, Owen, you are swearing because you're triggered now, so don't make me kick you out, please. I don't know how he does it. Arwin, I totally get it.
I just thought I let him go for a minute, and he just dives off in more shit, and he doesn't answer the question. He evades it persistently, and I'm sick of it. I don't care for your stupid mystery explanations if you never address any questions that actually address it.
Because we're looking for demonstrations, Arwin, and we can see in every...
Shut up!
We can see in every container.
Steam.
Whiny mouth. God,
Steam.
you're turning me into John. Shut up.
There you go, demonstration.
Hey!
Steam. I've given you a demonstration, you've ignored it. Steam. I gave a really concise explanation for it, Spurs. You've just ignored it completely.
Steam is a demonstration of what?
Of it being stuff, and you watching it press on a wall. Now, most times it'll just condense. It seems that I'm talking and you're constantly interrupting me, Spurs.
You're asking me a question.
I'm in the middle of a sentence. I'm describing it again and you're interrupting me again while I'm in the middle of the sentence, cutting my line. I can watch it. You're doing it now. You're doing it right now. Yeah, that's irritating, Spurs. I'm talking and yet you're talking as well. So, yeah, Spurs, it becomes a gas that you can see. You can visually see it as stuff touching the walls. Simple.
Right, so you've just said it yourself. That steam is not compressed. It's just in the air, just moving around this until it touches a wall. When it hits that wall, it will what? Liquefy and run down that wall. The particles of steam don't bounce off the wall or the window and then bounce back into the atmosphere, do they?
Yes, some of them do.
Can I jump in?
Some of them condense. Go ahead, Paul.
Okay. I've been doing some research on this, Spurs. Okay. Do you know molecules of gas and other substances have a charge to them? Do you know that?
No.
Well, okay. That's very important to remember, because what causes molecules to drop or molecules to form is the kinetic energy is reduced, and the charges within those molecules cause them to attract one another. Okay? That's what causes molecule or water droplets to form. The reason the molecule bounces off of the surface is that because they have the same charge, and it's like two magnets bounce, two positively charged or two North Pole magnets pushing against each other. That's why molecules bounce off surfaces, is because of the charge.
Okay.
Of the molecule.
Okay. So how high do the particles bounce off the surface of the floor of Earth? When they hit the floor, how high do they bounce back up? What's the height?
Until they encounter a force to stop them.
Yeah. So I'm asking. So when they hit a surface, they don't bounce back. You don't make any sense. So they bounce.
No. This is why important is to define what a force is. The idea of a force is a push or pull. Okay. When I'm pushing on my mouse to move it around, I'm adding a pushing and sometimes a pulling force to cause it to move. When a particle hits a contact with another surface, that force of it hitting it is pushed back by the surface, causing it to go in the other direction.
And I'm asking
That's a relative approach.
Hold on, Arwin. Go on, Spurs.
I'm asking you how high, Paul, when the particle, like Nathan says, the tennis ball hits the wall, we can measure with the force how far that ball will go. So you're saying particles come down, hit the floor. Well, how high does that particle bounce back up?
Until a force acts upon it to stop it from moving.
So if a force didn't act, how high would the particle bounce?
It would just keep traveling in that direction it was moving.
Yes.
So go down, then up, down, then up.
Yeah, look, gas pressure expanding is a separate force
Arwin, just let Paul. Arwin, please.
From displacement. I'm just trying to point it out.
Paul, are you saying the particle would come down and then hit up, bounce up straight back?
No, it would keep going in the same direction until a force acts upon it. Whatever direction that particle is moving.
So let's say one's coming from the sky, it's coming down, hits the ground. You're saying it will hit the ground and do what?
Bounce back in the opposite direction.
Right. How high? Or just straight back up?
He's already answered.
Until a force interacts with it to cause it to change direction.
Right. That's what I'm saying. So you'll say it goes back down and then straight back up until it hits the ceiling and then back down. Yeah?
I didn't say anything about a ceiling. I said a force, or I guess you could say some kind of substance that it would come in contact with.
So I'm asking you then, how high? What's that rate? What's the speed? The particle comes down. How fast?
Depends on the energy of the particle. What's the problem, right? Do you accept that it bounces, Spurs?
No, I don't. I'm asking him how high and where does it hit something when it goes back up, and what does it hit, and when does it? What's the speed? What's the rate?
Well, it depends on the particle. It depends on how much kinetic energy it has. There's a lot of factors, Spurs. So
the Heisenberg uncertainty principle.
You said you did some research. Give me one particle that you've researched that bounces, that goes up at a certain speed and comes down and hits something. What happens? What have you researched?
You want an example with something you can see? Okay, a steam room.
No.
Yeah, in the real world, a steam room. Yeah, it's not.
Have you ever watched Thomas the Tank Engine, Spurs?
Hold on. No. You're saying steam.
Yeah, they've harnessed this power. We realise that as well. Discord, well commented. So
you're saying steam.
Steam room, right? It's not condensing, is it? It's hot enough to keep it as a steam, isn't it? And you can see it.
Uh-huh. So
right, when it's bouncing, it's bouncing off the walls of the container, randomly in all directions. It's not that it's reaching the floor, bouncing, and then going, oh, I'm like a tennis ball in this example, and going, oh, I'm losing all my kinetic energy because I'm actually a solid. They're not solid. They're expanding in all directions, they're traveling in all directions, they're moving freely and randomly at high speed.
Is this a joke?
In a steam room. You haven't answered me. So is that hand wave dismissal to my visual example of steam not condensing on the walls of the container, but in fact bouncing randomly off the walls in all directions at high speed in random always? That's not a good enough example, is it not?
You're saying the walls are not soaked with water from the particles.
It's too hot.
Yeah, it's a steam room. The primary purpose being for it to be steamy.
Yeah, because it's coming from a fire, from a source. If you stop that source, that steam will just wet the walls.
Yes, that's correct. With that particular gas, it needs to be in a hot environment. That's just the parameters for that particular gas. Let's not worry about the parameters that create the gas. Let's just worry that we definitely have got a gas, and it's definitely not condensing, and it's definitely bouncing off the walls of the container in a way that you can see and not deny. We're waiting for you to say yes.
He's on mute.
No, I think you're joking. Also, I can't believe you even. I can't believe what I'm hearing right now.
What you mean a full description of how it works?
Right. So let me go through how I
can't
understand.
believe that.
Go through what? It's
let's say-
visually
Why not?
described.
Why not? What is
I've just
your
described
specific
it and then met
objection? And don't
silence,
bring
and
up
now
a new
Arwin's
story.
decided that the silence where he should be conceding is his time to argue with him. I've got a long pause silence because I've drawn him to the point where he can't argue anymore, Arwin. It doesn't need a new point. It needs him to concede. It's visually obvious in a steam room. He just left a long silence.
Right. This is why I have to ask: are you kidding or are you being serious?
You haven't denied anything. I've described something. A steam room. Steam being gas. Now you're talking. Steam being gas. Not a joke. A visual representation you may have even experienced personally, where gas is bouncing visually. You can see it in all directions moving randomly. This isn't a joke. It's a visual example of gas. Simple.
So, let's explain how I understand what.
No, let's get your... Oh, I understand that that's a visual example of gas bouncing off the walls of a container. And it's that visual representation. I haven't finished. I'm pausing to breathe. I'm literally taking breath. Yeah, breathing in the gas pressure.
Exactly.
So, Spurs, it's just a way of qualifying it so you can see that it's not vanishing, it's not disappearing, it doesn't stop being in existence when it becomes a gas. It's still there, you can still see it, and it's definitely just bouncing off the walls. But you haven't conceded. You now want to give a different description rather than say, yes, I understand. All you've said is this a joke. No, Spurs, it's not. It's a visual demonstration of
You can
the
even
point.
like your farts.
But am I going to be
I've
able to
done that
get
before.
through an explanation of what's going on or not? This is not something where you say concede because you've got it wrong.
You have got it wrong. Gas has pressure. It's the force exerted on the walls of the container.
Instead of just demanding that I agree, why don't you let me explain why you're wrong, and then see we can find out if you're wrong.
You haven't addressed why I'm right. I've given you a visual example, and you've said, "Am I joking?" That's your rebuttal. Essentially, Spurs, a hand wave dismissal to something that every member of the audience can visualize and understand. You've got something that is solid in the form of ice, liquid in the form of water, and gas in the form of steam. In certain circumstances, with a heater, as you put it, you can maintain its gaseous state and observe it doing what it does, moving randomly and bouncing off the walls.
Okay, this is incorrect. I'm going to explain why. When you have steam coming from a source, that steam will obviously build up in the room until it hits a wall. Once it hits the wall will start to absorb that water, and it will turn to, this is where you'll see the pressurized gases on the wall. The walls will start to drip. You'll see sweaty walls, you might call it. These walls will start to drip with the gases from wherever it's coming from, the source. If I use a kettle, for example, if I turn the kettle off...
Spurs, you're describing a phase transition. And I'm not interested in the phase transition. I'm interested in it when it's in that specific state of gas. I'm not interested in detailing the transition back to water. I'm talking about the gas that's not condensing, that stays in the chamber. It doesn't all instantly condense when it hits the walls. Some of it stays there. That's the stuff I'm talking about, not the stuff that's gone through the phase transition back to water. The gas, because that's what we're talking about.
Again, incorrect. in this high temperature, the particles are expanding, dispersing. They're not coming into a tighter ball. This would be impossible. It's not cold in there for the particles to condense tighter and tighter and start bouncing. They would expand more and more and more. And when they hit a real surface, like a wall, then they start to pressurize again, and you see the liquid fall down the walls. Very, very simple. You stop the gas, the room doesn't start to fill with gas all of a sudden. All the gas that's left, you will see on the walls.
No, no, that's wrong. You're telling me you're saying you can't see the gas in a steam room. You're just denying the very description of the thing I've got you to... And now you're talking over me. Of course. Why would you be doing anything else while it's my turn to talk?
How can it expand in high pressure? How can it collapse in high pressure? The gas is expanding, not collapsing.
Yeah.
We're talking about
how is it condensating on the top of that container?
The pressure is the real pressure.
But how is it condensating there if it wasn't in a gaseous state?
How can it?
Does it move in there through the sides in a liquid form?
It's just rumpusing the hell out of you.
Not solid. They're expanding. They're warm. They're hot. They're dispersing. The hotter it is,
dispersing,
the less they can be a particle. They've got nothing to condense to be a particle in the first place until they hit a wall. Once they hit a wall, they return to the form of a liquid under pressure.
No, they don't.
So they do
like
form into gas.
In the middle of the room.
So they do transit to gas.
You're acting like gas is just being built up magically from the middle of the room, and oh look, gas is just dispersing from the middle of the room. Look at all that pressure. No, it's coming from a single source, which is pumping out this gas, which is dispersing in high pressure. Cannot condense, so there's no pressure here. It's going away until it hits the wall. I don't have to repeat this. This is simple. You see this everywhere. In a container.
I'm pretty sure you don't.
In a contained environment.
I'm pretty sure if you have a kettle that's very hot, it's not gonna turn liquid again. That only happens in a distiller.
Low pressure, those particles would freeze. In high temperature, they expand. So where's the pressure?
He just said in low pressure. That's what he just said. So he's now even equivocating with the very term he's denying.
Yeah, in a container, in a steam room.
Yeah, that's the point of the argument. You need a container. Yeah, that's the only reason. And we know that gas does press on the walls. All of this is all understood principles. You're just being a denier. It makes no sense to me.
You get that. They expand, not condense. So how are they going to bounce if they're expanding?
Condense means phase change. That's not what we're talking about. We're not talking about the part where it changes into water. We're talking about what it does when it is a gas, not the phase change. You're focused on what happens when it hits the walls and there's a sufficient temperature difference for it to condense. Now, I'm not talking about that. I've tried to put the parameters such that the walls will not create condensation. Now, you're saying, yeah, but you still get condensation in a steam room. And you're right. I'm not going to lie and say that it doesn't happen. I've been in a steam room. It doesn't change the fact that there is still gas. That every molecule of gas is not condensing, but you'll just deny this.
But again, how can they contract? It's not cold.
What do you mean contract? We're not talking about the phase change. I've just said that. You've just ignored me.
But you're talking about pressure. The pressure here, where's the pressure? The only pressure is when they hit the walls.
So you accept that there is pressure then? Oh, great. Finally, a concession. Yes, the pressure is the force exerted on the walls of the container by the gas. Yes. Thank God. Can we move on?
We don't live in a container, Nathan. So the particles disperse. They don't bounce anywhere. The warm air rises. As they rise, they expand until they reach a cold area. Then they contract, lose potential kinetic energy and all that malarkey, and then fall back down. What are they bouncing off? I'm yet to hear where's this dough.
You're asking me what they bounce off, and you're denying the very bouncing. That's pressure. The bouncing is the pressure. Now you're asking me what they're going to bounce off. You're denying that they have any bounce.
No,
how dare you?
They don't bounce off the walls.
Yeah, they do. That's what creates, that's what is pressure. It seems like you're in this globe head mindset where you want to deny what pressure is. Because they need it to just fall back down again. To have sky vacuums. It seems like that's their next argument, and you're forming it for them.
Oh no, again, that doesn't form their argument. It just explains that we're being honest. We don't know what is up there.
We do.
We don't know what
so you are on their side, aren't you?
Up there. No,
So
the ball
you
earthers
are with
say-
the ballers
Ball
then.
earthers say they have been up there.
We make no positive assertions in that regard, Spurs. Well, at least I don't. I know there's plenty of flat earthers out there that absolutely do make positive assertions, and they can make it by logical deduction. I don't make any assertions about the skies, but for the fact that we have gas pressure, which you seem to want to deny. Well, gas pressure absolutely is the force the gas exerts on the walls of a container. That's what gas pressure is. Now you're saying, well, the only way around that, and the only reason I can see you want a way around that, is to make space real.
No, not space. Containment doesn't mean container.
Yeah, it does. They're the same bloody word. Containment, container, yeah, same thing, Spurs. To be contained, you need a container.
Hold on. When it rains and it goes into the water, the water, that's not a container, is it? So you can go into the water yourself, but
Why are you constantly talking about water? We're talking about gas. We're talking about a fundy assertion that we've got a sky vacuum and the nature of gas and how it presses on the walls of the container to give you gas pressure. That's how you get it in the first instance. To be gas pressure, it must have pressed on something. If it's dispersing infinitely, it's never going to press, therefore is not pressure. But you want to deny the very nature and ask me what something's pressing on.
Objection.
Even if it's liquid water, you still have to have a container. Even if it's liquid water, you still have to have a container. It just doesn't have to have a top on it because liquid water has hydrogen bonds.
What this does, Nathan, this
You
Newton's
still have
law
a
about
container. You
objective
still
motion
got a
must stay in motion.
sides to have water pressure. You have to have sides and a floor. Hello.
So what's the roof of the water, of the sea? Where's the roof?
You don't need one.
Exactly.
Exactly, because water is liquid, and liquid water has hydrogen bonds. You don't need a top
Fish,
on
let's say fish, for example. Fish
because
can't
it's a
leave
false
the water,
equivalence fallacy,
right?
Spurs.
Did you hear what he
Fish
just said?
can't leave the water, can they?
Yes, Spurs, it's called a false equivalence fallacy because you keep using the terms of water. And we're not talking about the behaviour of water, we're talking about the behaviour of gas.
Yeah. And what happens to gas when you compress them?
I have a question for Spurs.
What happens to compressed gas, Nathan?
I mean, what happens to it?
The
molecules get... Okay, I'll answer you. The molecules get closer together. What's your point?
Yeah. So you have a gradient, right? It's denser at the bottom, yeah?
Well, it just means that if they're closer together, there's more of them to press on the walls. Therefore, the measurement of how much is being pressed on the walls goes up.
Right, so that liquid that's at the bottom...
No! What part of gas don't you understand, you complete retard?
So you're saying, hold on, let's get
Did you
this
hear what I
right.
just said to you? I'm tired of this. I'm going to round out the show shortly, but you've really pissed me off for the last hour. What part of gas don't you get? Not liquid.
That's what happens to gas when they're compressed.
For the love of God, we are not talking about the phase transition. We are talking about the state. It's a gas, not the transition back to liquid, not liquid. Gas. How many more times? The state, not the transition.
There's a difference between gas and pressurized gas.
Gas is a pressure when it exerts a force on the walls of its container.
Who kicked him?
Who kicked him? Somebody kick Spurs? Or did he just lose his
I
connection?
was just about to. I wanted to ask if Warrior beat me to it.
I didn't kick him. I can't kick him.
Okay, well, there was supposed to be a presentation. I've been watching the time
Yeah,
throughout.
Riley, it was you, wasn't it?
I want Paul to get the last word in, and then we will have a second show because I'm going to do a presentation. So there'll be an after show. Stay tuned. Paul, you can have the last word.
Sweet!
No, wait, he left?
Yeah, hang on a second.
I did not kick
He
Spurs.
left.
I did not kick Spurs.
It's all right.
No, yeah, sorry for the accusation.
Spurs.
It's old habit.
Before you start, Spurs. Before you start, Spurs. I'm going to round out the live show in about a minute. We're already late. But Paul's going to get the last word, then I'll round out the show, then we can continue this in the after show. Is that okay?
Sure.
Yeah, I can get some breakfast.
Oh, is it going to be
do
John
whatever you
instead of
like.
me? Okay.
I'm not your mum.
We're going to have a second show. I can get some breakfast. Cool, go.
Right, you're on, Paul.
Okay, first, real simple, real basic. Water has 3 states. It can become a solid, a liquid, and a gas, all dependent upon the kinetic energy in the molecules. Simple. I'll leave it right there. We'll come back off after the show is rounded out and come back on the next round.
And with that, I'll say, if you are watching this on the Nathan Oakley premiering stream, then stay tuned, as there will be an after show to follow. However, if you're watching live on Nathan Oakley 1980, then unfortunately this is where we bid you farewell. A huge, massive, enormous thank you to all of you who smashed the super chat, liked, commented, shared, subscribed, and all that good stuff. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley. Stay tuned if you're watching on the premiering stream, and I'll see you all in the next video.
Oh, what a day! What a lovely day!